Welcome dear students once again to my YouTube channel Knowledge Entertainment. And once again we are here for solution of more harder, typical and tricky problems on trigonometry. I think it will be continued in one more video and then we'll proceed on to the next topic, that is trigonometric equations, and then inverse trigonometry and so on. So I'm going to start some more questions on trigonometry. These are a little bit more tricky problems, a little bit more harder you can say. So the first question of the day, I'm starting with this question. The question is, if tan x is m upon n, then show that under root n plus m over n minus m plus under root n minus m over n plus m is equal to 2 cos x over square root of cos 2x. This is what we want to prove, and we are given that the value of tan x is m upon n. So I am going to solve this problem for you. Once again, I'll start this problem from left hand side, and left hand side in this question is under the root n plus m upon n minus m plus under the root n minus m upon n plus m. So we are having here sum of two expressions, both are in numerator and denominator form. So what we will do, we will divide each and every term of the first expression as well as of the second expression by n. So when we will divide each term within the square root in the numerator and denominator by n, and here again each and every term in the numerator and denominator by n, so it will become square root of this n divided by n will be 1 plus m upon n over n upon n is 1 minus this is m upon n plus similarly in the second expression you will have 1 minus m upon n over 1 plus m upon n. Now you are having m upon n in all the four places where we are having a known variable, and the value of m upon n is tan x, so substitute it here throughout. It will become square root 1 plus tan x over 1 minus tan x plus this is 1 minus tan x upon 1 plus tan x. Now, substitute the value of tan x at each of the place as sin x upon cos x. Take out LCM and a little bit simplification. You will get square root. This will become cos x minus sin x upon cos x plus sin x plus in the second expression you will have square root cos x minus sin x upon cos x plus sin x. Now take out LCM of these two expressions, of these two terms, and the LCM will be square root of this is cos x plus sin x, and it is it is at one place it is plus here and minus in the denominator. I'm sorry for that. So this is minus, and in the second expression it is cos x plus sin x. While taking LCM and then solving, this under root cos x plus sin x multiplied by under root cos x plus sin x will become cos x plus sin x, and this is plus, and this under root cos x minus sin x multiplied by under root cos x minus sin x is cos x minus sin x. So what we are going to get here, the sin x will be cancelled out. This cos x plus cos x will become 2 cos x, and in the denominator this cos x minus sin x into cos x plus sin x is cos square x minus sin square x, and we know it very well that cos square x minus sin square x is equal to cos 2x, which is our required right hand side. So it is the way how to prove this question. This was the first question of the day, and now we will move on to the second question. As we are going ahead, questions are becoming a little bit more tricky, a little bit more harder, a little bit more, you can say, difficult. Now, the next question, what we are going to solve today, it is once again very good question. The question is find the ratio of maximum and minimum values of this expression given as 2 minus cos x plus sin square x. So we are given this expression. We have to find the ratio of its maximum value and its minimum value. That means what we have to do, first we will have to find its maximum and minimum values and then their ratios. So I am taking this quantity as in the solution as y. So let y be equal to 2 minus cos x plus sin square x. You can write it as 2 minus cos x, and this plus sin x can also be written as 1 minus cos square x. This 2 plus 1 is 3, and you can take minus common from these two terms. So minus cos square x plus cos x in the bracket. Now, to make it perfect square, it is a square plus 2ab, and now what you need plus b square. That means square of half of the coefficients of this term. Coefficient of this term is 1. Half of the coefficient is 1 by 2, and its square is 1 by 4. So add 1 by 4. But there is a minus sign outside the bracket. That means actually you have not added, you have subtracted 1 by 4. And if you have subtracted 1 by 4, then you will have to add 1 by 4 as well to make it an equilibrium. Now, this 3 and this 1 by 4 can be simplified as 13 by 4 minus this bracket is now cos x plus 1 by 2 whole square. This is your y. Now we want to find y maximum and we want to find y minimum and then their ratio. For y to be maximum, this quantity is fixed, this is negative. So when it will be minimum, y will be maximum. And it is a perfect square, its value cannot be negative. So what can be its minimum value? Its minimum value can be 0 when cos x is equal to minus 1 by 2. So y maximum will be obtained by putting the second quantity as 0. So the maximum value is 13 by 4. And for y to be minimum, this quantity has to be maximum. And it is a perfect square, cos x plus 1 by 2 whole square. The maximum value of cos x, we know that it is 1. So the maximum value of this expression is 1 plus 1 by 2 square. So y minimum will become 13 by 4 minus maximum value of cos x plus 1 by 2 square. Simplify it. It is 13 by 4 minus, this is 3 by 2 square, and 3 by 2 square is 9 by 4. So it is 4 by 4, that means equal to 1. Is it its minimum value? Now, ratio, the required ratio is y maximum value divided by y minimum value. Y maximum was 13 by 4 and y minimum is 1. So the required ratio is 13 upon 4. This is the required ratio of the maximum value of the given expression to the minimum value of the given expression. So this was the second question of the day, and now we will move to third question of today, and this will be a little bit more tricky question, I think. The third question is, I am going to write it first as statement of third question of the day. Evaluate 2 times sine 1 degree plus sine 2 degree plus sine 3 degree and so on up to sine 89 degree divided by 2 times cos 1 degree plus cos 2 degree plus and so on plus cos 44 degree and plus 1. We have to evaluate this quantity. The question is looking a little bit tricky, and yes, it is a tricky question. So how to solve it, how to evaluate it? What the trick we will use now? We will make pair of the terms in the numerators. I will make pair of sine 1 degree with sine 89, sine 2 degree with sine 88 degree and so on. So what you will get? You will get 2 times, in the numerator it is sine 89 degree paired with sine 1 degree plus sine 88 degree paired with sine 2 degree plus and so on. The last pair will be of sine 44 and sine 46, and then I am going to write the last pair, sine 46 degree plus sine 44 degree, and one term will be left, and that is sine 45 degree. This term will be left alone. In the denominator, you are having 2 cos 1 degree plus cos 2 degree plus and so on plus cos 44 degree and plus 1. Now it is further equal to, this is 2 outside here, this is sine A plus sine B, and we know that sine A plus sine B, or you can say sine C plus sine D, is 2 sine C plus D by 2, sine C cos C minus D by 2. So applying the formula here, it is 2 sine sum of the angles divided by 2. Sum of the angles, this is 89 plus 1, 90 divided by 2 is 45 degree. So 2 sine 45 degree, and then cos difference divided by 2. Difference is 88 divided by 2 is 44 degree plus, similarly the second bracket, it is 2 sine 45 degree cos, the difference is now 86 divided by 2 is 43 degree plus and so on. In the last we will get 2 sine 45 degree, and the difference is 2, now divided by 2 is cos 1 degree, and this is plus 1 extra, sine 45 degree, 1 additional term, sine 45 degree is here, divided by, denominator I am not going to change, cos 1 degree, cos 2 degree and so on, plus cos 44 degree and plus 1. I'm not going to change the denominator. It is now 2. This sine 45 degree is throughout common. Sine 45 degree is throughout common. So I am taking it as common. And the value of sine 45 degree, we know that it is 1 by root 2. So I am substituting the value as well. So 2 into 1 upon root 2. And in the bracket, you will get this 2 cos 44 degree, 2 times cos 44 degree, plus 2 times cos 43 degree, plus and so on, plus 2 times cos 1 degree, and this last term will become 1. This is your bracket and divided by. Now I am opening the bracket in the denominator. It is 2 cos 1 degree plus 2 cos 2 degree plus and so on, plus 2 cos 44 degree and plus 1. If we look carefully, then this bracket in the numerator is same as the denominator, so it will be cancelled out, and this root 2 upon root 2 will become equal to root 2, and it is the required value of the given expression. So this was another tricky question, and another tricky question will follow now. The fourth question of the day. We have solved 3, and as I have told, one more video is to come now after this one on more and more tricky and difficult problems. The next problem of the day, I am going to take another good question, and this question is, if 2 times sine z plus x minus y is equal to sine y plus z minus x plus sine x plus y minus z, then show that tan x minus 2 tan y plus tan z is equal to 0. So as you look into the question, it looked like more tricky as compared to the previous questions we have solved. This is a little bit more tricky question, and yes, it is. Now how to solve it? The problem is how to solve it. The given expression, I am going to write this 2 times this term as 2x as x plus x, so I am going to write it as sine z plus x minus y plus sine z plus x minus y is equal to sine y plus z minus x plus sine x plus y minus z. So I have written this 2x as x plus x. Now I will take this term to the right hand side and this term to the left hand side. So what I will get then? This will become sine z plus x minus y minus sine y plus z minus x is equal to sine x plus y minus z minus sine z plus x minus y. Now left hand side as well as right hand side is sine c minus sine d. So the formula I can apply 2 cos c plus d by 2 sine c minus d by 2 on both the sides. So I am going to apply the formula. Your left hand side will be 2 cos. Now sum of the angles z plus x minus y plus y plus z minus x divided by 2, and then sine. Now difference of the angles, that means z plus x minus y minus z plus x by 2 is equal to, on the other side once again, 2 cos sum of the angles x plus y minus z plus z plus x minus y by 2, and then sine difference of the angles x plus y minus z minus x plus y divided by 2. So let us look carefully. Whatever is being cancelled, this minus y plus y is cancelled, this x minus x is cancelled, this z and minus z is cancelled, here minus z and z is cancelled, y and minus y is cancelled, here x and minus x is cancelled. So look at the quantity. What we are left with, it is the 2 is also cancelled. This 2 on both sides is also cancelled. So what we are going to get now, it is cos, this is z plus z by 2, that means cos z, and now sine, this is 2x minus 2y by 2, that means x minus y, is equal to, on the other side, cos x plus x, 2x by 2 is cos x, and sine, it is 2y minus 2z by 2, that means y minus z, and now sin x minus y and sin y minus z I am going to expand. You will get cos z, this is sin x cos y minus cos x sin y is equal to cos x into sin y cos z minus cos y sin z. Open the brackets on both the sides. You will get sin x cos y cos z minus cos x sin y cos z is equal to cos x sin y cos z minus cos x cos y sin z. Now divide each term on left hand side as well as on right hand side by cos x cos y cos z. So when you divide the first term by cos x cos y cos z, cos y and cos z will be cancelled. You will be left with sin x upon cos x, that means tan x. The second term, when you divide it by cos x cos y cos z, cos x cos z will be cancelled. Sin y over cos y will become tan y. Similarly, on right hand side, you will get tan y minus tan z. And now carry both the terms on the right hand side to the left hand side. This minus tan y and one more minus tan y will become minus 2 tan y. You will get tan x minus 2 tan y, and this minus tan z will become plus tan z is equal to 0, which is your required result to be proved. So I think this question was a little bit more tricky as compared to the previous questions, and the next question I think will be more tricky as I am taking the questions from easier to harder way. So what I am trying to start with a bit easier questions and to end with a little bit harder problems. So in this way, the next question what I am having today is this question. The question is, if cosecant theta minus sin theta is equal to A and secant theta minus cos theta is equal to B, then find value of a square b power 2 by 3 plus ab square power 2 by 3. We have to evaluate this term. We are given that cosecant theta minus sin theta is equal to a and secant theta minus cos theta is equal to b. So first I'll solve these two and try to find a little bit more easier values for a and b, and then I'll substitute the values to evaluate the required term. So for the solution, as given, This cosecant theta I am writing 1 upon sin theta minus sin theta is equal to A. This implies taking LCM from the left hand side, sin theta, you will get 1 minus sin square theta is equal to A. Now 1 minus sin square theta is cos square theta. So the value of A is coming out to be cos square theta upon sin theta. In the similar fashion, you can solve the second equation and you will get the value of B to be equal to sin square theta upon cos theta. Now A and B are in easier forms. Now we will look at the required term. The required term is A square B power 2 by 3 plus AB square power 2 by 3. Substituting now values. First of all, it is A square. So A is here. So what is A square? Is cos power 4 theta divided by sin square theta and multiplied by B. B is sin square theta upon cos theta and then raised to the power 2 upon 3. Similarly, in the second expression, first it is A. A is cos square theta upon sin theta into B square. B square is sin power 4 theta upon cos square theta and then raised to the power 2 by 3. What you are going to get now? This sin square theta will be cancelled. Cos cube 4 theta over cos theta is cos cube theta raised to the power 2 by 3. Similarly, the second bracket will be sin cube theta raised to the power 2 by 3. Now power to the power will be multiplied, so this 3 will be cancelled and you will get cos square theta, and similarly the second expression will be sin square theta, and we know very well that cos square theta plus sin square theta is 1. So I am going to stop this video here. In the next video we will solve some more tricky problems, some more harder problems, some more difficult problems from the point of view of entrance examinations and engineering entrance examinations like IIT, JEE and MNR and so on, NDA. So before leaving you here, I would like to thank you once again for liking my videos, and I hope you will again like my videos. You will share these videos with students, especially 10+1 students and the students appearing for the engineering entrance examinations, and you will subscribe this channel and you will ask your friends also to subscribe to my channel. Thank you once again. We will meet in the next video.